Welcome back to our point 7. We are continuing our radical and rational expressions with example 4. Basically, even roots always have to be positive underneath. And we talked about that yesterday in our first example. Even roots must always be a positive base, otherwise it is not real or imaginary. From here, I'm not going to worry too much about the absolute value, but we just kind of want to simplify this as much as possible. P to the fourth power, and this is a second root. Power over root, 4 over 2. 4 over 2 reduces to p squared. And so this will be our simplified form. Letter B, we have p, fourth power, fourth root. 4 over 4 is 1. So we can answer as p or p to the first, but just remember that 1 is not going to be written there if it were multiple choice. Letter C, we have 16. This is a first power and a second root. We have m, eighth power, second root, r to the sixth power, second root. Simplifying this, 16 to the 1/2 power, or the square root of 16 is 4. 8 divided by 2 is 4. 6 divided by 2 is 3. And so 4m to the fourth r cubed is our simplified form. Letter D. Our base is -2, sixth power, sixth root. 6 over 6 is 1. So -2 would be our simplified answer. Letter E. We have m as our base, fifth power, fifth root. 5 over 5 is 1. So m, or m to the first. We are not going to worry about f or g. Radical rules. So just like exponents, radicals have some rules to help us along the way, hopefully simplify things for us. Again, this should be a multiplication in here in that little box. But what this is saying is if you have two radicals with the same root or the same index that is being multiplied together, then you can multiply their bases. An example of that would be if we had the fourth root of 2 times the fourth root of 8, then we could multiply 2 times 8 to get the fourth root of 16. Notice we are not changing the root. We're only multiplying the numbers underneath because now basically we're looking for like terms or like radicals or like roots. The quotient rule says the same thing. I can go either direction here. So I'll give an example of each. Let's say that we have the seventh root of b over 49. We can rewrite that as the 7th root of b over the 7th root of 49. We could go the opposite direction. Let's say that we have the 5th root of 12 over the 5th root of 2. We can say, because those are both 5th root, I can make this one big fraction of 12 over 2. Why would I want to do that? Because 12 over 2 is 6, and I can simplify it that way. Our last rule, the power rule, that line should say product. If you have a radical of a radical, then we can make that one radical by multiplying their indexes, or which root it is, together. Sample of that, let's say that we had the 7th root of the 3rd root of z. I can rewrite that then as 7 times 3 is 21, so the 21st root of z. And that would be simplifying it. Let's take a look at some of these rules. Example 5. These are supposed to be multiplying. So we're going to simplify these as much as we can. Letter A. These are both the 2nd root or the square root. So we're allowed to write 6 times 54 as one single radical. 6 times 54 is 324. And I can go on my calculator and say, can I take the square root of 324? And in fact, I can. It's 18. And so this would be our absolute simplest form. Letter B. Our radicals are both the 3rd root. So that means I'm allowed to put m times m squared. Remember, this first m is m to the first. Exponent rules say when I'm multiplying like bases, I add the exponents. 1 plus 2 is 3. If I rewrite this as base m power over root, I have m to the 3 over 3 power, which is just m to the first, or m. Letter C. I can't reduce 7 over 64. And I know I always want everything as simple as possible. So I'm going to use the rule where we can separate this into 2 separate square roots. And so I still can't take the square root of 7. But I can take the square root of 64, which is 8. Square root of 7 over 8 would be as simple as that gets. Letter D. I'm going to rewrite this again as the 4th root of 8 over the 4th root of b to the 4th. Doing that, I cannot rewrite this top one unless I put a to the 1/4, which doesn't really help me reduce. B, though, 4th power, 4th root. 4th power, 4th root says then that I have the 4th root of a over b to the 1st, or just b. Letter E. and the 7th root of the 3rd root of 2. My base is 2. And remember, we multiply our indexes together. So 7 times 3 is 21. So this is the 21st root of 2. Letter F, I have the 4th root of the square root of 3. So I'm going to put a little 2 here. My base is 3. And multiply these two together. 4 times 2 is 8. So that result is the 8th root of 3. Pause it and work on the next chunk of practice, please. Simplifying radicals. So, no decimals. If it says estimate or round, then you're allowed to have a decimal. But if it's all it's asking you to do is simplify, then it wants you to break down the numbers, pull out what you can, and then everything else stays inside. I like making factor trees for this. 175 ends in a 5, so I know I can divide by 5. 175 divided by 5 is 35. 35 I know is 5 times 7. I can't break any of those down further. Those are prime numbers. Because this is a square root or a second root, then you need pairs to pull out anything. So we have a pair of 5s here. That means that I can pull 5 out, and this 7 gets stuck underneath the square root because it didn't have anybody to come up with. Letter B. This -3 we're not going to worry about right now. This 5th root says that we need groups of 5 to take it out of the radical. 32, I'm going to do 8 and 4. 8 is 2 times 4, and the 4s are 2 and 2. So I have 1, 2, 3, 4, 5 2s, and I need a group of 5 in order for that to come out. For every group, you only write it down one time. So I'm pulling out the 2. I already had a -3 here, and this operation between the -3 and the radical is multiplication. I don't have anything left. We broke down all these values. There's nothing left inside the radical. So all we have here is -3 times 2, which is -6. For this last example, this 3 says that we need groups of 3 to be able to pull out stuff to simplify. So for the 81, I'm going to break that down. You know, 81 is 9 times 9, and each 9 is 3 times 3. I have one group of 3 3s, and that 3 gets stuck. So this I'm going to pull out, and this one's going to go back in. From here, there's 2 ways we can look at these remaining values. I can write out 5 x's and circle a group of 3. So I have one group of 3 x's. I have 2 x's left over. I can do that same thing for the y's and the z's. The other way we could do that is if we said, well, Power over root, 7th power, 3rd root. How many sets of 3 can I pull from 7? 2. What's the remainder? 1. Z power over root. 6 divided by 3 is 2, and there is no remainder. And so here is how we would simplify that expression. Let's pause here and practice. Thank you for joining me.